All right, so now we're going to look at an example of doing our and probability. And notice that the big difference between these two problems are we see the words with replacement and without replacement. Okay? So this is again something that was brought up in the previous section, and it is something that you will kind of continue to see as we go through and look at some different problems. So 2 cards are to be selected with replacement, and 2 cards are going to be selected without replacement. In both cases, we're looking for the probability that 2 queens will be selected. Right? So our probability of 2 queens using our multiplication rule is going to be the probability that our first card is a queen times our probability that our second card is a queen. Right? So if we think about our probabilities, the probability that the first card would be a queen, well, we have 4 out of 52 queens. Right, with replacement means we're going to draw a card out. Once we're done, we're going to put it back into our deck. So we put that queen back in. Well, we still have 52 cards to choose from and 4 queens left in there. Right, so then we're going to go ahead and reduce this. Both of these reduce nicely to 1 over 13. Then if we multiply this, this gives us 1 over 169, or as a decimal, 0.0059. So a very, very, very small chance of drawing 2 queens with replacement. All right, so 2 cards are going to be selected without replacement. So our basic formula is still the same. We're still multiplying our probabilities. Right, our first probability is still the same. Right, the probability of drawing a queen from a brand new full deck of cards, right, is 4 out of 52. Now, the difference between A and B, again, are these words with replacement and without replacement. So since we don't replace this card, that means that we only have 51 cards left to choose from. So we're actually going to change that denominator. Right? And since we don't replace that card, if the first one we draw is a queen, well, that means that out of our 4 queens, there's only 3 left. So we end up taking 4 out of 52 times 3 out of 51. If we reduce these into lowest terms before we multiply, that's going to give us 1 out of 13, because those are both divisible by 4. 3 and 51 are both divisible by 3, so we get 1 out of 17, which then we can multiply to get 1 over 221, or 0.0045. So a slightly smaller chance then of drawing 2 queens without replacement. So when you're working through and thinking about problems with decks of cards or other things, make sure you're paying attention to the idea of whether or not we see the words with replacement or without replacement.